Geophysics from Geology and Reservoir Department, Oil India Limited, Duriajan, Assam. He has done MSc Tech Exploration Geophysics from Banaras Hindu University, Varanasi. He also did his MTech Mining Geophysics from Indian Institute of Technology, IIT ISM Dhanbad, and PhD in Geophysics from Banaras Hindu University, Varanasi. Some of his research interests are seismic, gravity, magnetic data acquisition, process-simulated, integrated interpretation with various geoscientific data for hydrocarbon exploration, shallow crustal modeling, inversion, delineation of truss fault, sedimentary thickness mapping, basement depth estimation, etc. He has also presented various technical papers in the national and international conferences and published numerous works in peer-reviewed Indian and international journals. Also a member of SEG, EAGE, SPG, IGU, AEC. With all this, I would like to present my sincere wishes to Sir so that he keeps on excelling in his field in the years to come, and we are pleased to have you with us. Now, may I request Dr. Gopal Krishna Ghosh, sir, to kindly take over the session. Thank you, and over to you, sir.
Thank you so much. So I would like to thank you, Petroleum Technology Department, Dhrubajyoti University, for inviting me for these valuable sessions. And I would like to thank you all the participants in this online conference. And let me start. Just prior to that, I would like to share my PPT. So that let me confirm first. Is this audible, these slides?
So it is visible.
So so once again, thank you. So today's topic is environmental issues and challenges in seismic survey. So what are the issues during this seismic survey we generally faced, and how it impact to our environment, and what are the mitigations, and entire things will be discussed in this current sessions. So my slide is changing, I think.
Yes, sir, it is changing.
Okay. So today's topic is divided into various subtopics. First is introduction of seismic survey. Then I'll discuss about the what are the techniques involved in seismic survey, and then what is the effect of seismic to our environment, and what are the seismic activities, and then it is how it is affected to land and marine life. Then mitigation, measurement, and recommendations, and summary and conclusion. So first, if we see this seismic survey, we can see that our compound annual growth from 21 to 28, it is increasing. That means industry people still, they are deploying the fund for acquiring the seismic survey. So if you see that global seismic market share through 2020, we can see that this entire acquisition part, interpretation and data processing, which is a compact seismic survey, that and 50% is we are involving our money to seismic data acquisitions, and further we invest in processing and then interpretation. So by service, we can divide this entire seismic survey in three parts. If you see this global seismic survey market from 2016 to 28 onward, and we cannot see any COVID effect to this seismic survey, that if we forecast what will be the 28, the market value in USD billion, that it is increasing continuously. So there is no impact of seismic survey this post COVID, but the production, the drilling part, it has been affected. But the seismic survey, there is no impact on this. If you see in global scenario, that entire seismic survey activities, if you see this in terms of various region, North America, Latin America, Europe, Asia Pacific, then we can see that these are the countries still in there are chances that they're still working in the seismic survey market and they are associating, and we can see that compound interest growth is still 3% in this Asia Pacific. So further, we can see that this seismic survey market still due to in COVID region, but in Africa, Middle East, there are very big scope we can see here. First of all, I would like to discuss about this geophysics, and which is this seismic technique is part of this geophysics method. So geophysics is the branch of exploration physics, experimental physics dealing with the earth, and exploration of the earth analysis the physical properties of this material. So physics, geology and mathematics, this entire three combination which produce geophysics, that can be seen that various methods, geophysical, there are various geophysical methods. One of these is seismic, and that how it impact to our industry in global scenario, that we will discuss here. If you see that this seismic method, which is dependent on this acoustic impedance, there are others method, but this seismic method, which is globally we are using around more than 90% for accuracy, this method generally used. That's why this is very important. Now in seismic, earlier days we have seen that there are various techniques, 2D, 3D, 4D, 2D, 3C. Like this, so far we have now reached Q marine technology and then crooked line seismic. So these are the development so far in seismic. Now, what is seismic? How it is impacting the ground and how we are acquiring data and interpretation and how it is impacting our environment, that will be discussed. So seismic waves generally divided into body wave and surface wave, and body wave further divided into P wave and S wave, and lav wave, Rayleigh wave and T wave, that is the part of the surface wave. So what is P wave? P wave, if you see here in this figure, that P wave generally call it is primary compressional and longitudinal wave. It is transmitted through liquid and it is faster than S wave, and particle motion are in the direction of propagation. If you see here that directly it is compression and rarefaction is there, but in the case of S wave, there it is called secondary and transverse wave. The particle motion is normal to the direction of wave propagation and it is slower to this P wave, and it cannot pass through the liquid. So this is very important properties, that S wave, if there is some oil and gas, that S wave cannot pass through this, So if it is some fluid content is there, so this is very good uh, to prove that as wave it doesn't pass, that means there is some fluid is there. And further is surface wave. Surface wave generally which is moving along the surface, and as the waves that can travel through this surface and is spreading to medium. Particle motion is complex and maybe in elliptical and slower than S wave. Surface waves are noise and spreading through the uppermost layer of the earth and decreasing its amplitude with depth. So this is, and if you compare this Rayleigh wave and lav wave, you can see that that is a vertical retrograde motion in Rayleigh wave, and lav wave which is passing through this horizontally, and particle motion like this, and though it is direction of propagation. Now, in seismic survey, generally we see that surface seismic and borehole seismic. But here, I am not going to discuss this borehole seismic, but I am going to discuss this surface seismics, and these are basically refraction and reflections. So what is reflection method? Seismic reflection survey generally, when we are passing through some energy through the ground, it's generally reflected back and it's recorded towards geophone or seismograph. So these are the some pictorial examples seismic reflection method where energy source is there, and we are sending this energy and it's going through the ground and reflected back and recorded by various detectors. And these are the various formations. So these are the different layer, and these are the some explosive and partly reflected, partly transmitted like this energy. So as it goes down, their energy generally decreases, and we, that's why this reflection method has certain merits, and it can give some idea that what will be our target depth and what are the different formations. Through using this seismic energy source, we can detect, we can find out, we can estimate that what should be the velocity layer and what type of rock material is there through seismic reflection survey. Generally, in seismic reflection survey, we use the deeper target body. In the case of refraction survey, we generally see for the shallower target up to 50 meter or 100 meter. So in both the cases, seismic reflection survey for deeper body and seismic reflection survey we are using for the shallower target. And this is just partly this is a refracted wave. So this is coming, and that as per the principle total internal reflection, that is going back, and we are recording in the same detectors. So these are the type of seismic shooting generally we use in field. If our detector in one side and our source is another side, then this type of shooting is called the end-on position or single-ended shooting, because that source is one-sided and all the detectors, suppose your 200 channel or 500 channels are spreading here, and we are keeping source and we are shooting, such kind of technique is end-on shooting. But if our source is in between and our receivers both the sides, then this type of shooting is called broadside on position shooting or symmetrical or split generally we term it. There are various advantages and disadvantages. As we know that this seismic survey gives the detailed study, and we can find out the more accurate survey, and directly it is detect where is hydrocarbon, and it gives a very good image subsurface, and that velocity also we can find out. And disadvantage, there are some few also there, that equipment is very costly, it requires a lot of time, and it is very much expensive, and it is a lengthy process and complex process, and it needs planning required. And the very important drawbacks of this method is impact to this environment that we are going to discuss here. So general discussion on seismic instrument. What are the instruments generally we use? So these are geophones. Okay. If it is generally we use in land, and if it is in marine, then we generally use hydrophone. So these are the some graphs, some figures. We can see that internal configuration of this geophone. These are some spike we are keeping putting in the ground, and there is some coil and magnet, and if it oscillate vertically oscillate around this ground, that generates some EG current, and that current we calibrate, and then we find out how much voltage or how much that way we can see what would be the amplitude. So these are the some graph. We can see that geophones are planted, and this is recording equipment. So it is laptop it is taking. That may be 24 channels, simple geophone plantation. So, and this is the hydrophone. We are putting this. Um and these are the some surveys. So this is the marine survey, mainly measure in travel travel times and amplitude, which depends on the density and the elastic modules. That this is sheep, and it is sending some ray, and different layers are there, and there are various hydrophones, and they are recording through this. And this we are through this energy source we are using here air gun, that water air gun, that is generating some pulse, and that pulse going down, and then from different reflect it is coming back, and we are recording. So the next is what are the land source and what are the marine sources. The explosive, vibrators, wave drops, mini-source, and shear wave source, wave drop, vibrator, land air gun. And these are the some land and marine sources we will see here. So if we use the explosive, what are the impact through this ground? Just see. When we put explosive, that generates some smoke, burn, then shock wave, and through this that can give some pollution to this environment. And and this is some very good result. So before that, it's giving some destructive nature from the environment, but the output from the seismic survey, it is very good, and we are getting some final concurrent, or this where is oil, where is the gas, like this. But the impact of the seismic is very very, if we don't take proper way, then this may be hazardous, and it can create problem to our environment. So we need to take care. So these are the very beautiful results. Now another survey is generally used in seismic survey, that is vibrator. We use vibrator in place of seismic, where explosive we cannot use, then we can use vibrator. So these are the some pictorial diagram. Sorry. Sorry, I think it is disconnected. Hello. Is this audible? Is this
Yes, sir, yes, sir. It's
okay?
coming.
Some problem. I don't know why it is disconnected.
Okay.
Some slide is not moving. I Yeah, that's some slide issue, I think. Is this okay?
Yes, sir.
Yeah, this is some vibrator which is used for seismic survey, and that generally some graph we are using. We are sending some pulse to the ground and various, and they are coming from the return path by one, path two, and three. There are three different layer, and this signal is coming back, and they are interfering through this. That what type of layer is there through this pulse we can find out. So this is the different way. Now, land and seismic source, one seismic source is weight drop that we generally put drop here, or it is through hammer, and we generate some pulse, and that pulse gives some seismic signal. That is through this signal is coming from the weight drop. So we just hitting. So in place of explosive, this can be used. So that is also very good. And another seismic source generally we are using, it is the Manisosi. That is just like a hammer, and it is connected, and it's for a very shallow depth we generally use, and that generates some noise, and it is good for resulting in a random impulse transmissions. So that also some vibrating rammer seismic source and changing the striking rate by varying the engine speed. So these are the some results from the seismic survey. So another is land seismic. So that is hammer and plate. We have some plate, and we are just spreading some line, and by planting geophones, we can see what are the output. So these are the some output results, which is hammer plate, and then further we interpret this, and we can find out the depth of target. And then man is the marine source air gun. Marine source air gun, we have already discussed this thing. In marine, we use this marine air gun. So we just send it and we generate some pulse. So it is a air gun array. There are a lot, 4 5 air gun, or it may be more than more around 10. Within 10 we are putting it, and different array we configure, and then at a time one by one we can just we can uh, generate pulse. So individual air gun that hanging pairways below the frame position. So particularly then we put down this inside the water at particular 2 meters, around 4 meter, or within this 6 meter we generally put it. So that, and it generally creates some that pulse, wave pulse, and that pulse and through the water, and from different layer of the water it just map this. So these are the some and then when this single air gun we put it, what type of signal we generate. So when we put air gun inside this water, it generates some air bubble. So initially that gives a very high impact. That air gun generates very high impact. That impact can cause damage to fish or nearby flora, that nearby that animals live inside this water, that like fish or any other things that can impact. So that air gun which is generating this pulse, this gives a very wrong impact to them. So that we need to be configured, and we need to do some mitigation that we'll discuss in next part. So these are the some impact from signals. We are getting some different type of layers. So through air guns, and we can able to map the subsurface from below the water. So these are the some impact. Okay, then 2D seismic data acquisitions. Let us just brief about this. So that we have seen that when in the case of 2D, just we have along a line, and we just source and another side receiver, and that one by one we go and it detect different type of different layer information like this. In the case of these are the 2D output. These are the signals output received from the seismic survey in the case of 2D, and there are some different type of information you can see. And this one, this is not signal, this is the facility noise. It may be from instrument, or it may be from air like this. And this is reverberation. This is ground roll, that a ground wave is coming there. Then it is air blast, and that is harmonic noise, it is continuous, and that is vehicle noise like this you can see at particular time. So, and these are the signals, these are the fast arrival, you can see this is noisy. Now we filter this data, we filter this data. So from this data, if we don't filter, we cannot get any information. But in the case of processing, we do. That's why I just inform that seismic data acquisition part is there, but it needs a rigorous processing. So that is time consuming. So if we process the data, then we get the different, very clear cut information that about the signal. So through this, we can get what are the information inside that. This is very clear. Now in that way, we can find out and we can get that some reflections are there. So in the case of 3D case, generally we see that there is some source line and another is some receiver line. This red dot, it is showing that it is a receiver line or a receiver line, geophones we are spreading like this. And these vertically triangles are our source line. So when we spread, there are various lines, about 10 lines we spread it, and then we blast one by one point like this. So this is called swath. So these are the some geometry. We can see that various receiver line and at a time, suppose 1,000 receiver will collect from a particular source, then that is called a template. So like this, so at a particular single shot, entire geophones covered within this template will receive the signals. So these are the like this. So this is this 4 line, if we mix and do survey, that is called swath. And like this, we'll leave this line and we'll incorporate this line. Like this, we can make a pair of 4 line that can give you different swath information. These are the receiver's record, 6 channel output we can see. And the important is foldage of data. So when we try to cover a particular area here, but the output data, what we get, that process that is for interpretation required, that is in terms will be lesser quantity. Suppose our area, we cover this area, but our full folded data, which is marked in the white part, that gives the various information regarding our subsurface. So despite of acquiring entire data, there are some partial data acquired here, that is called taper part, sometimes inline and cross line taper, that we need to remove. And then this red one, that will be our full foldage data. So what is full fold data? That we will discuss. The fold we can calculate for 2D cases and 3D cases, and which is dependent on our number of channel spread and how many receiver line and cross line. And that way we can calculate fold for 2D cases and 3D cases. So in the case of subsurface target area, I just explained earlier that this blue line, you can see that acquisition we need to be covered. And then if you want processing, then you will get that much process data for, and further this in one area, it is showing that will be for eligible for interpretation, where entire information can be available. So seismic data processing, that is very complex procedure. There are various steps. So this is, I'm not going to discuss here. So there are various steps. I can tell that these are the steps here. So after this process data, how we get our seismic data, that I'll just going to show. So these are the some output data we got from the field, but we see that after 2.5 seconds, there is no information at all. So there are one processing step is we need to amplify the gain for that. So after applying gain, now we can see that automatic gain, that we are some subsurface information or reflections are, it is visible. So another process is that when we take some survey, that we need to do some time correction. So we need to calculate. So as soon as our geophones are away from this source, that with difference of time, these are some time lag. So we need to correct it. That is called some NMO correction. So that at 0 time, what is the impact of this reflection that we can get. And now if we sum up all these things, we get one signal. that is called the stack. And that if suppose here 8 channels are there, then this will be 8 times stack. That is called 8-fold data. So that is the thing. Suppose here you have 4, 8 and 3. That is 11-fold data we can get it. So that can give a very good information in place of different one. So if we merge it and we can get, so this can give very good information. That is called foldage. This is the same way. So this is stacking. Suppose in the case of we record this data, it is called 5-fold. Suppose see the information which is we are getting here. These are not very much very clear. You can see some scanty data and these are not very regular. But if we increase the foldage, suppose 50-fold, you can see that there are some continuous information we can get it. So like this, these are the some comparison. You can see that 5-fold data, 50-fold, how it is good. It is here the information is not available, but here we are getting very good information. And there is some NMO stack and DMO stack, deep move out. If we suppose our inside ground is dipping, in that case we cannot apply NMO. In that case we need to apply DMO. So after DMO correction, you can see there are a lot of changes. This has been removed here, and here some scanty, here we are getting very good. And these are some noise, cross coupling noise are here. It is not visible here. And further you can see DMO. If you do migration means repositioning, exactly how our subsurface are located, that is giving very good information, actual position, that is called migration. So if we can apply DMO and migration, then we are getting a very good result. You can see, compare this NMO stack and DMO stack, they are very good difference. You can see here it is some cross coupling is there, but these are all removed here. Here we are not getting signal, but here we are very good signal. So these are the impact of seismic survey, seismic signal, seismic how we are getting, and how this seismic source is utilized. Based on this we are getting this information. These are the some processing strategy that finally migrated sections giving the better result. These are the results. So now we are going to seismic interpretation, though it is not topic. So these are some basic steps we generally use, and these are the some seismic results we generally get it. But what are the impact of this seismic activity? The impact of seismic activities on the environment and their mitigation we are going to discuss here. So in seismic impact, we have already seen that physics, geoscience and ecology, and there is a common point that all these three methods give some impact, and which is giving very role that we will discuss here. So if you see some result, we can see that 100,000 times louder than a jet engine, which gives the seismic air gun that we are through in marine survey. What seismic air gun is using, that pulse is generating, that is 100,000 times louder. So you think that what will impact to the fish or any aquatic animals present in this water, that what impact will happen to them, that there is another way, some pollution noise day to day, suppose how it is affecting our brain, our day to day, our thinking process, our day to day activity, and this impact of noise to this aquatic animal, how it is happening, how they are affected, that see. So when it is a steamers and they are sending some air gun pulse through this, they generally come here and they directly reflect back. So this is the deeper part, and like this reflected back, and in between there are various type of aquatic animals are there. They are partly affected from different type of apart from seismic, there are different type of equipments in our we are sending pulse, and through this they are created noise, and through these waves, various fish, various type of aquatic animal are affected. So this physical characteristics and variation of regarding sound propagation through the water column and seabed and how they are affected we can see. So further this source, seismic source is coming down and further reflected. That is particularly affecting our aquatic animal. That means I mean to say. So seismic activities onshore, offshore, and oil exploration. So these are the activities that which is particularly in seismic field. These are coming from blasting, then seismic exploration study, using an explosive charge. We are using vibrator, we are using pipe cable through explosive, then land gun, air gun, like this. These are the sources which are impacting in our environment. Further we can see that these are the effect you can see through this pictorial graph, how it is affected to the fish, how it is affected to the water pollution, and you can see their status, the fish status, then how these animals are affected when we are using air gun pulses. This seismic blasting here, you can see that how they are injured. So seismic explosive, what happened? Seismic leaves, water quality, marine animals, marine bird, aquatic plant, fish, marine mammals, entire marine environment, habitat loss, primary effect that may impact on marine life, and they have some adverse effect to man. So these are the impact happen through the seismic explosive that kills this. Further, they can pollute drinking water, crop and vegetable also affected, damage the environment, that can create noise, environment damage, and water table impact, and water quality also impact. Seismic impact on fish. Generally when we do seismic survey, that reducing their ability to find food, fish are affected, and that physical damage to their fish ear, tissues, organ such as swimming blades, and may not kill fish immediately, but decrease their ability. So reduce catches fish around area where air guns were being fired. These are the some idea. So you can see some impact on this fish. Seismic survey impact on bar. We can see that this sound effect, due to this seismic survey, that bird flew off from their fishes, and due to sound, it can movement in and around mangrove for shooting purpose like short hole drilling, shooting material transportation, and also disturb bird as well as other mangrove fauna. Birds used to fly off their perches and stop singing, calling, reduce the ability of migratory birds to acquire the energy for successful for migration. The seismic explosion is transient in nature, though, but there is no permanent impact during the process of seismic explosion activity. That there is this effect is though it is looks very dangerous, but it is not a permanent, and it is a transient effect. So that can be, we can take some recover. So before seismic activity, we can see that there are 90% there is no change, and after seismic blasting they can fly, and further after seismic activity it is flying status is less. So we can that see that there is some transient effect on this part. In the case of snake, you can see that before seismic survey they are very active, but after seismic survey their life just like cool, they do not have any action or move on this. That is also a transient effect. Marine mammals also be affected by this activity, and they are also habitat loss, noise disturb activity, then spoil water activity from the seismic survey. Then skin surface inhalation, like this muscle and liver, these mammals also by temporary disturbed through this activity. Then water quality, that water quality also change. Water quality will be non-hazardous waste and drinking water. I think these things has been discussed in your things. But through the seismic survey, we can see that these explosive contaminated things that through land and marine survey that can affect the water quality also. The waste of explosive that also contaminated through blasting, and it can mix up with water and give some hazardous things. So it is also dangerous to mammals, bird that are drinking this water, and water table also changes. So in the land survey or in land survey, we do some seismic survey at particular depth at 20 meter like this. In that case, what happens? Some water table, suppose in a very shallow level, that water table sometimes goes down, and that way that can change the water table. And through explosive it goes through the ground, and it that contaminated and with chemical through this ground, and gives some um, impact to the water quality, that animals who drinks, that can affect, that can change quality of this water. But if you see proper way seismic survey to be done prior to proper survey, and identifying the different zone to reduce the risk quality. So these are though there, but still industry is using. So how it is used to be used, how it can be taken up some mitigation, that will also be known. So that impact on land habitat also, these are also like this flora and that aquatic animal like this. Through this land habitat, that can also due to this blasting can also give some water quality change, that dust deposition, reduce photosynthesis on plant, destroyed small plant. And then sometimes what happen, effect of surface layer on soil, moisture content, soil temperature, wind direction, that also change. So we can see that there are a lot of changes through the seismic survey. Seismic impact on marine animal, that we have already discussed. That man-made sound can injure some of the marine animal, we have already discussed, and cause behavioral change. That louder, that air guns that pulse is generating, that can, which is very louder, that can affect the fish like aquatic animals, and increase the pathological stress and separate it from their young, who turns with the becomes easier. And like this it is very much affected. So how seismic survey impact to man, that really this is very important. That seismic through seismic survey, the gas flares that generally come out, it is very much harmful, and it gives a very poisonous chemical that come out, that may include of nitrogen dioxide, sulfur dioxide, benzene, like various dangerous gases that also come out, and that can give some impact to the respiratory problem. Finally, it can cause some blood related disease, then sometimes cause some acid rain, that can give, people are affected through health issue, and they can give some skin lesions. And like this it can impact the growing field, and whatever we are getting from food through the surrounding plant, that also be affected. So these are indirectly affecting this human. So another way that that's why sometimes what happen in this particular area, seismic survey area, we are getting some changes of environment, that migration of man and animal. Sometimes wells come out, and sometimes the wastage of drilling and that industry setup, that can also impact the particular area. Now, what are the mitigation? Let us see what are the mitigation we can take up. Mitigation measures on fish, that whatever the air gun we are using in the ground, or whatever the explosive we are using in the waters, that in ocean or sea or nearby around these water bodies, that to be taken care. And in the short hole, whatever we are using in the land, that discharge or that output which is disposal coming out to, as a mud cutting like this, and which is mixed with the water and going ultimately to the water body, that need to be taken care, and must avoid altering the steam bank and obtain necessary approval for survey. For any particular seismic survey, it need to be taken approval. And next thing is using of explosive. How much explosive we should use? That should be quantified, and it should be some proper guideline from the government. Generally, we use less seismic we should do less seismic activities, and when there is exact not required seismic survey and there is some alternate, we have some alternate seismic survey, we go for that. Just like we can do some vibrosis survey, we can do some any other survey like gravity, magnetic, any other geophysical technique which can give some role and equivalent to the seismic survey. So that to be checked, and equivalently we should do it. In the case of bars, in the bar sensitive area, we should avoid this, and we should make some centuries or like this. So we should make some minimum distance from stream and water bodies. Restricted entry should be avoided in the vicinity of the nesting site. So seismic survey in any particular area, responsive counters measures to be taken up, like for water spill bodies. So that's to be guided from the government guideline. Mitigation and marine animals. It is also the use of explosive for seismic activity should be restricted in marine water, and lessons are required for the implement while spill prevention control and counter major plant. Seismic survey must comply. Again, it is from the government guideline. So for the marine animal also, in which part we need to do survey, suppose in the coast or any fish populated area, or somewhere the aquatic animals are there, that area need to be taken first approval, and how it need to be taken care, that need to be get some approval from the government. As per the government guideline, we should do the seismic survey. So mitigation measures to protect water quality, that is very very important, that whatever we are seismic survey using, the in the case of explosive, I am talking in terms of explosive, how we can take some mitigation, that drinking water protection is very much important. A freshwater aquifer monitoring while with water quality monitoring should be requires down gradient of the permanent storage facility unless alternative acceptable technology is approved by government. Then the drilling waste, well spill prevention and control, and losses must include in their well spill contingency plan. So method for detecting, responding to, controlling blowout, and location of the identification of the oil spill cleanup equipment, the location and availability of the suitable alternative drilling equipment, and plan of operation to be mobilized, drill a relief well like this we can do. So disposal of the produced water to freshwater bodies, then intertidal areas and estuarine water is prohibited. So while spill prevention control losses are advised to must prepare contingency plan so that we can do some cleanup of well spill. Mitigation of effect of land and habitat, that way also we can take up the wetland protection, then drilling waste for offshore deployment, and surface discharge of drilling waste while spill prevention control can be taken up. So mitigation of man, this is very important. So limited application of seismic survey to be conducted. And in the case of area, suppose we are doing some seismic survey in various part of this area. So which area we are taking seismic survey, that we need to first identify whether it is a village, such kind of village or forest area or sanctuaries, what type of areas are there. So based on this seismic survey to be conducted, and what type of seismic survey to be conducted, whether it should be explosive or it should be vibrator or any other seismic survey, that can be first identifier. So limited short hole. Suppose any highly populated area, we should use very limited short hole, so that contaminated explosive cannot be very much mixed with the soil or ground, or it can affect the water table. Then short hole blasting waste to be collected in proper disposal requires as per the government guidelines. Then in the case of number of seismic source we can take up, but nowadays advanced technologies are there, so we can do some recovery sorts, and we can minimize the sort that explosive by applying recovery seismic sorts. And then we should use the latest state of art technique that seismic survey can give, that without with less explosive or with different seismic technique, that with the we using minimum explosive we can get a maximum output of seismic data. Then in the case of seismic, then vibrator is the alternate source which can be used in place of seismic explosives, that can be given importance in place of seismic that explosive. Other non-seismic methods also to be given importance, gravity and like gravity and magnetic survey. So these are the some ideas, the seismic survey, how these are how these are dangerous to this environment, and how these can be taken off to reduce their role, to that can facilitate to environment, to benefit to this aquatic animal and various kind of creatures surrounded, and in environmental impact that can reduce. So one thing that uh, for seismic survey, if it is there, so government should take some necessary approval and these are some recommendation to do seismic survey and to safeguard the environment and reduce the mitigation effect. We should take prior measurement, and we should follow the government guideline for proper seismic survey with limited use of explosive. And in place of explosives, we should use vibrators as a alternate seismic source, which can give less impact to this environment. And we should use alternate seismic methods like gravity and magnetic, MT, electromagnetics we can use. And we should use the latest technique of seismic without quality loss. So that need to be taken care. So we should then further we should identify the sensitive zone. Sensitive zone in the means, it may be centuries, it may be the fish, it may be uh, fish populated that see where the fish populations are there. It may be this villagers dense populated area that need to be identified. We should make zone, and based on this zone, what type of seismic survey and how much explosive to be used, how to minimize this explosive, we need to be survey. And then identify the sensitive zone, fish zone, bar zone, dense populated zone, etc. After that, we should make some guidelines that this particular area, what is the water table, and what type of survey can be taken up, need to be reviewed, and that need to be taken from the government approval prior to do seismic survey. Then we need to collection of explosive waste, proper disposal. When we do survey, suppose in any particular area we go for seismic survey, as you know that our 90% of the oil and gas exploration use seismic survey, and that seismic survey use a lot of explosive, and ultimately these are going to ground, and that can affect, that is affecting our grounds, that is affecting our water quality, that is affecting our water table. So this is a very challenging role that explosives issue use is need to be reduced, and need to be properly this survey to be properly done as per the government guideline. So collection of explosive, whatever the waste, it is very much important, and it needs proper disposal. So further, when we use our seismic survey, there are a lot of machines are there which are further some oil spill, and that is generated some some waste coming out. So that need to be also collected, and it should not reach to sea or some land or water covered area. That need to be taken care. And more important thing is that we should do some research on that, that such kind of things is there, though it is very much important to do seismic survey for oil and gas exploration, but parallelly we need to see that how best we can give you utilize this method that cannot hamper our environment, that can preserve our environment without much impact. That research is very much required in place of use of explosive, and what are the alternate possibilities need to be find out through research. So oil and gas development during the exploration, construction, operation process should be done with utmost care to reduce its effect on marine life and its environment. And next is the last is that government and industry should step up in by providing fund to get research, and we should do proper survey prior to that. And these are the conclusion. Almost discuss. We should due care. Seismic activities can be carried out with less impact. Seismic survey to be carried out with strict condition and must comply with the government guideline. Proper research to be there, and care should be taken to prior survey and environmental impact assessment to be carried out, and strict adherence of government guideline is very much important, and more research and technology is required to such kind of survey, and to reduce the impact to our environment. That's all. Thank you.
Thank you, sir. Thank you very much for this practical and engaging session. And there is one question in the chat box. Is there any new blasting technology that replaces chemical explosives with non-chemical equivalents in water service, such as sonic blasting?
Yeah. Sonic blasting. That's sonic blasting. Just like if you see sonic, how it will come. Sonic blast, that we need to generate some noise. Okay. So that noise that we generally we do sometimes without explosive, with explosive. If it is with explosive, then it will give some impact, that the explosive contaminated, that explosive parts which can mix up with the land and water, that can give some impact, and it can damage, because this is high impact, it can damage the very high noise, and that can produce some damage to bars and house like this. But in case of sonic, suppose some another way, whatever we generate this, that can sound pollution is always there, but in place of explosive, yes, that land air gun can be used, and alternate energy like whatever we are generally using vibrator, that which is generating that signals we are sending through just wave, that sonic wave we are sending, that is okay, through that can be done through vibrator. Is this clear?
Thank you, sir. There is another question in this chat box. Every day, geoscientists detect this seismic activity of the Earth minute to minute from a wide network of observatories around the world. Can this daily seismic data be of benefit to the oil exploration companies so that they feel no need to carry out their surveys for the sake of the environment?
Okay, just is this can you read again the question? Oh, it
Everyday
is there. Okay.
geoscientists, yes,
Okay,
yes.
okay. Just wait, just wait. Every day, geoscientists detect the seismic activity of the Earth minutes by minutes from a wide network observations and around the world. Can this daily seismic data be a benefit to the oil exploration companies so that they feel no need to carry out their survey for the sake of environment? But see, the data is there, but why we are doing seismic survey? Because that suppose 20 years back some data has been collected. Now our environment, our surrounding, that we are doing survey for getting oil or gas or some subsurface detection. So it is continuously changing, because well, today in what particular depth it may change due to certain, suppose you have lot of extracts on last 20 years you have taken. So I think well may reduce their water table, that well may reduce quantity, and that 20 years before what we are getting some information today it may not get. That's why we need to do a continuous seismic survey, a continuous interval of time. That's why it is a repetition of seismic survey as per the requirement. Suppose I am targeting today for 2 kilometer depth. Now my requirement is 4 kilometer, 5 kilometer. That's why my seismic strategy, seismic survey strategy is changed. So I have to do some necessary parameters to get the depth for 5 kilometer. Earlier it may be for 3 kilometer. Now our well is not in the subsurface, but it is below 5 kilometer, 6 kilometer, and whatever the that we need to do a survey. So it is required for that.
Thank you, sir. Any more question? So if no questions from participants, I would like to offer my deep sense of appreciation and sincere thanks to Dr. Gopal Krishna Ghosh, sir, for giving such an excellent coverage on the topic environmental issues and challenges in seismic survey activities. Before we end this session, I would like to ask sir to be with us for a couple of moments, as we'd like to have a group photo session with our resource person and the participants. Participants are requested to turn on their videos for the photo session. Thank you all. I would like to thank all the attendees for being in this session and making it a successful one. We'll meet again in our next session at 3 p.m. Thank you, everyone. Thank you, sir.